So at Mirax, we help you avoid some bad situations. Imagine you're in the ISS station and suddenly the life support machine stops. It's not a good place to be in, but it's the same on Earth. If you power electricity to a big city, you can't afford even few minutes of downtime. And downtime and incidents, they cause big expenses to companies, especially in conditions where you just can't monitor. You have to stop the machine to be able to monitor because the temperatures are too high, because you have high voltages, high electric fields, explosive atmospheres. The reason is that electronics just don't work in this condition because it will melt, because it will explode, because the signal will be degraded. You find this in a lot of industries, but as well, for some signals, sometimes they are too small to be detected because the source is too far, because you have clouds, other conditions where electronics is not powerful enough to be able to detect it. And here, for these two issues, we use light instead of electrons to measure this into tiny chips using the same processes that are used to make electronics, but we do it without electricity, we measure with light. So we offer sensing solutions to be able to measure things that are not measurable with electronics. So with our solution, you can detect the undetectable and you can access the inaccessible. And our sensors are also so sensitive that they can be used to connect quantum computers together. And I'm more than happy to discuss with you how we do this. We are happily supported by the ESA BIC incubator and exploring all the space applications. I list a few of them here. If you have issues in monitoring propulsion systems, if you have to improve SATCOM systems, etc., more than happy to discuss. And if you're not into space, but you have to do monitoring, mapping of infrastructures in critical conditions, please come to us and we'll show you what problems we can solve together. Thank you.
Hi everyone, my name is Mina Kamel, co-founder of Voliro. With Voliro, we are revolutionizing work at height. We are developing advanced area robots that can solve the problem of working on elevated structures. The main idea is that when you work on, when you have high or elevated structure and you have to perform physical work like painting or inspection on these structures, this can be very dangerous, expensive, and time-consuming. So we want to replace people that are in difficult to reach areas or in hazardous environments with a flying robot that can perform these tasks. The robot we developed is a flying robot that has tilt rotor capability, so the rotors can tilt around the body, and that enables us to have thrust vectoring capability. This makes the robot able to approach structures at different orientations and exert substantial amount of forces on structures. So non-destructive testing or spraying or coating on elevated structures becomes feasible. And one of the key elements we are including in this robot is that ability to fly very precisely close to structures. So when you have outage of GPS or not available GPS sensing, you fuse visual inertial navigation capability and onboard sensing to achieve precise positioning close to structure. We have also the capability of performing 3D modeling around the structure and precisely report where the measurements are taken on the asset. So here a demonstration of how our robot is performing on one of the factories here in Switzerland, where we inspect or detect corrosion on one of the silos, where the robot basically approaches structures and perform non-destructive testing. Data is also reported on the ground and is stored for further processing in the next step. Now we are also able to operate indoor and outdoor, so the flying robot is not fully dependent on GPS. When GPS is not available, onboard sensing will kick in. And here we are basically inspecting pipes on inside a structure of ETH. Here we are demonstrating with Bouygues Energies and Services the inspection of power line transmission towers. And this basically translated into a commercial agreement where we are performing the inspection of the assets owned by Swissgrid. And here we are inspecting the quality of the coating of these power line towers. And as you can see, the robot is able to inspect areas that are not easily accessible by a human. So we have a wide range of application: non-destructive testing, ultrasonic or dry film thickness, spray painting, coating or cleaning. However, our initial market entry is focused on non-destructive testing. Other applications will be explored in the future. Our main need right now is to basically push the structural integrity of the drone. We are using lightweight material. There is very strong connection to aerospace, where we are using composites. And of course, one of the main tests we are looking for is wind tolerance, or testing in windy conditions. And finally, we are always looking for better components, better motors, better parts that we can make our drone more robust and more reliable. Thank you, and come talk to me here if you have any questions or you want to discuss any point. Thank you.
Hello, I'm Christos. I'm a co-founder of Rare20, a company dedicated to disaster analysis. So water, wind, fire are major forces of nature, and Rare20 was created in order to quantify accurately the catastrophic potential of these three elements. Floods, storms, wildfires are disasters that have huge effect on societies and leave a long-term mark on economic activity. And this problem is actually exacerbated today due to climate change. Rare20's scope is enhancing resilience and adaptability level of communities and companies to the new reality. Historic data are useful, but not enough anymore. And that's why Rare20's technology is a physics and data-driven engine that is suitable for analyzing any real or scenario-based catastrophic event. The technology development is based on the combination of computational tools for the detailed simulation of the physics, so the motion of the catastrophic medium, and analytics and artificial intelligence methodologies for the smart incorporation of the relevant data. The uniqueness of this holistic approach is the efficient use of existing real-world data and the creation of the necessary missing data. Two examples here showing the applicability of our engine. On the right, an insurer wanted to know the exposure to a certain flood event that occurred in the past at individual building level, and on the left, a dam operator was interested in assessing its liability for different dam failure scenarios. As a startup, initially we had a lot of questions about market opportunities. Thankfully, during the first year of Rare20 operations, we received quite an overwhelming, actually, response, and we provided our services to a wide range of industries, including insurance, utilities, and urban planning. What made Rare20's technology feasible is the availability of data and the evolution of high-performance computing. Data is at the heart of the engine. Currently, around 50% of the data we are using come from space. All kinds of socioeconomic or environmental data coming from any kind of technology or source are key for us in order to identify implicit hidden risks. Our aspiration is to create a super-fast engine accessible via a platform which could be used even for real-time disaster monitoring and mitigation planning. And towards this end, high performance and sophisticated parallel computing and sophisticated data handling infrastructure is essential. Insurance, financial markets, logistics services, civil protections are among the client segments where we can provide our services. And we look actively for partners willing to work with us and develop these opportunities and render our world climate ready. Thank you very much.
Hello everyone, I'm Pierrick from Pictera. So as you may know, there are approximately 100 terabytes of data, images that are collected every day by 2,000 Earth imaging satellites. So we expect this number to reach 6,000 satellites within the next 5 years. So the question is, of course, how can we create value out of this huge amount of Earth observation data? Well, you don't have so many solutions, actually, but machine learning. And, well, this is when the problem starts with machine learning, is that it first requires a lot of training data. The second thing is that if you want to use machine learning, you need to have some high-level skills, high-level expertise in computer vision, and, of course, machine learning. So, basically, let's say that the only way to extract value out of Earth observation data is not that accessible today. So what we did and what we're doing at Pictera is that we created a new way to train machine learning model. I won't call it AI, but well, so we invented a new way to train machine learning model. So anyone can now train a customized artificial intelligence to detect, localize, and map any object anywhere on Earth. Our solution is simply, I would say, the best solution on the market. It's, let me check this one. Yeah, it requires 99 times less training data. It's 90% less expensive than the traditional method. And ultimately, this is 100 times faster than any other solution on the market. So now, if we look at the, basically the business opportunity, the existing Earth observation industry is an existing 400 billion market. But this is only the top of the iceberg. So if we manage to basically bring both access to Earth observation data combined with artificial intelligence, we could have a very deep impact on almost all the mainstream industry: real estate, insurance, agriculture, transport, you name it. As a few examples of what is possible to detect, when I say, well, you can detect anything with Pictera, that's actually the case. So you can detect buildings, cars, but even road cracks, cattle, literally anything with our platform within a few clicks and without having any skills in machine learning. So the solution is obviously scalable, defensible in some way, but besides of being backed up by proprietary IP, our platform is backed up by a strong network effect. So basically, this network effect is powered by a community of 7,000 users who made in more than a year the platform 10 times faster. And this community of users, they created all together probably one of the largest library of pre-trained algorithm, pre-trained detector. And we reached this month 300 detectable objects. I would say that what we're doing today is almost an excuse to build something bigger, which is basically the Google search for the physical world. We want to make the Earth surface searchable, and we want to bring this new knowledge accessible to anyone. So we don't sell a software, we sell the capacity to tap into an untouched reservoir of data, insight, information. So every student, entrepreneur, any company can tap into this reservoir of untouched data to build their own business. Thank you very much.
So at MicroR, our slogan is passion for precision. And what we're passionate about is this: lasers. In particular, making lasers with very, very pure colors. One of the challenges facing industries like telecommunication, sensing, quantum technology is not having lasers with pure enough colors, because this causes noise and problems for their systems. So at MicroR, what we have is a very compact laser system that allows us to supply lasers with colors that are 1,000 times purer than typical systems. The need we're trying to fulfill is that many of these applications really do need lasers with purer colors. What this enables them to do is to be more precise and to see things more clearly. The problem is that it's very challenging, actually, to find lasers with pure colors. So normally a laser like this, it might look very red to you, but in reality, it's many shades of red, and they're all moving around very, very quickly. And so at MicroR, what we have is a very compact solution that allows us to make lasers with ultra-pure colors. So who cares about this? So our markets for MicroR are a couple-fold. Our target markets are both quantum technology and LiDAR. In quantum technology, I'd say about half of the new quantum technologies coming out require lasers with very, very pure colors. In addition to LiDAR, which is using lasers to measure distances and velocities of objects very precisely, by having a more precise laser, you can be much more accurate. As well as for telecommunication, whereas you want higher and higher data rates, this can be enabled by having lasers with pure colors, as well as in sensing applications. In the space sector, we're already active developing next-generation lasers for space-based optical atomic clocks. So our solution is something called an optical microresonator. Long story short, it's like a very precise filter for light. And with that, we can make compact lasers with colors that are 1,000 times purer than typical systems. So right now, what MicroR needs is we're currently raising a seed round investments. We're in discussion with initial pilot project partners and looking for more, as well as looking for industrialization and product partners, as well as people to help us along the way and help us build another ESA BIC success story. So my name is John Jost. I'll be happy to tell you a little bit more later if you have some questions.
Today is a demo day, and I feel like doing a demo. I don't have my chip here, but I'm going to say, OK, Google. Hey, Siri. And I'm pretty sure a few of your phones have woken up. That's the problem we are solving. The problem with chips today is that they are not powerful enough to run algorithms that are sufficiently complex enough to be really contextual. Imagine you are in a room with 10 people, and one of you says, OK, Google. All your 10 phones are going to wake up and process that command. That is not what you want. You want chips on devices that really understand context, that respond to the actual command that is issued by the user. You want chips that really adapt to the situation. It understands context. It looks at the camera data. It looks at the audio data. And it does it real time. It's always on. It doesn't kill your battery within a few hours. And it doesn't heat up your device all the time. And then imagine the possibilities. This goes on your clothes. You can wear watches. And your phone can actually become like your Iron Man suit. Jarvis can be real. Algorithms exist. You can play AlphaGo. You can beat computers, beat humans in everything as long as it's sitting on a server. But if you put it on your phone, it really sucks. It's bad. And that's the problem we are solving. Our chips are at least 10 times, in most scenarios, at least 500 times more efficient when running AI workloads. And it does it in a way that is fully compatible with existing hardware and software solutions. We have a pretty complex way of selling things. I will not go into depth about it, but we typically work with other companies that make hardware. And we provide our solutions to these companies to enable their products. So if you make a drone, you should talk to us. If you're making a wearable device, you should talk to us. If you are sending a robot to space, some kind of a micro robot, you should talk to us. We will allow you to build a system that's truly smart and can truly operate without requiring charging every few hours. And for the past few months, we have been working with a number of organizations, some of which we met through ESA. And we have been very successful in getting good pilots across. And we are now in a very good situation to start making progress towards our Series A funding round. Which brings me to what I would like to achieve here. If any of you is working on a hardware company, that's building any kind of a product that has need for AI algorithms, we can support you. And we are also willing to help you train the algorithms themselves. So as long as you have the expertise to build the rest of the system, the intelligence is for us to handle. And of course, as we make progress towards our Series A, if there are investors, please track us. And you'll hear more about us in the coming months and years. Thank you.
So hi, I'm Patrick, and we provide global insights, local insights for real estate professionals. Now let me introduce you to the real estate market and what I'm talking of. Professionally managed real estate covers $8.9 trillion of managed portfolios traded on public markets. In Switzerland, the pension funds have over 100 billion invested in real estate. That's your money, that's my money. And that market is undergoing a big change at present. We see that there is a strong need for diversification that is leading in three directions. First, a diversification in terms of niche markets. We all heard about WeWork, co-working, shared living spaces, logistics for AWS. That's the niche segment. The second one is the globalization. We see portfolios that covers multiple countries. The Credit Suisse portfolio is going into 21 countries at present. And the last one is indirect investments. That is fast investments through tokenized real estates. Now that you have a basic idea of what's going on in the world, we want to give you an insight on what actually the portfolio manager is doing. That's the person managing that real estate portfolio. He needs to do decisions on his own for large portfolios and to define custom strategies. The strategies are custom and thus not standardized. And we see that there is no solution for customization. We see no solution for any global strategies because we don't have consistent data streams. And we see that most players simply don't have any expertise in working with data, data science, geoscience, and the interpretation of it. And this is what we do. We support portfolio managers in accessing data simply anywhere worldwide, implementing their own know-how, and at the end, deploy it in their team for the actual uses. The acquisition, the management, and the change and trading with real estates. Now you might ask why we're here in the ESA BIC program. Now our applications is what the users see and use without any know-how on machine learning or geoscience. But the strength of our platform is the data behind it. We characterize spaces in a way that allow you to create insights out of spatial structures. We do this with algorithms that we developed at ETH, that we licensed, and that is implemented in our own machine learning framework in order to process efficiently insights out of point data. Point data that come from our clients, point data that come from contracts. And we deploy this back into the platform so that everybody has the option to use their own machine learning algorithms without any know-how. We have only started or incorporated 5 months ago. We still have pilot projects that are running. We have licenses sold for our platform. And we just won the venture competition as first place in FinTech. We, that is a team of data scientists, geoscientists, and real estate experts. And we are very interested in pilot projects. And Phil, if you listen to this, I also want to talk to you because we're using AWS. Thank you.
Great. Hello, everyone. At Compare, we believe in a world without material waste. And I really like to start with the fact that human beings like you or me are able to live for 80 years. but most of the products we use every day last only a few years. This is a paradox, no? And for us, that's exactly how it started, being inspired by nature to extend the lifetime of composite applications. Composite materials are applied to many industries thanks to their lightweight properties. They can be made of glass, carbon, or natural fibers, embedded in a resin to create structural components. Even though they are very great, there is a big issue during their lifetime. Small cracks that grow more and more until catastrophic failure. And this is a global problem. Because people repair those small damage, and this costs $17 billion per year. But not only that, for many applications, people just replace parts, generating a very high amount of waste. So this raises big question of sustainability as well as lifetime management. And with Comper, we are bringing the solution to reduce maintenance cost and help the environment. So our solution is textiles that are pre-impregnated with our magic chemistry. We sell those to part manufacturers and OEMs for them to manufacture full composite parts with new functionalities. An ultra-fast and efficient repair, as well as an efficient recycling. And this has demonstrated many benefits on the marketplace. To demonstrate our technology, we manufacture several demonstrators, but specifically that one, which is typical of the aerospace industry. We impacted it, and here you can see a typical damage in the middle of your screen. This can be just a small spot for you, but in the industry, this is already critical, and people will spend many hours to repair it. With our solution, this is simple. We come with a heat gun at 150 degrees for 1 minute, and it's done. You recover all the initial mechanical properties. And I have a live demo here afterwards if you want. The beauty of this technology is that we can have multiple products with one magic chemistry, and we plan to extend our product portfolio to best meet the market needs. With Comper, we can touch the entire composites industry. However, we need to focus to best launch our venture. We have now an industrialized product, the Hilltech series, that is currently being shipped to the first clients into the marine and sports industries. Our space connection lies into the use of our Comper products to build space structures, and this has demonstrated many potential benefits. Our current needs, we are fundraising to secure our market entry, looking for strategic partnerships, and the next step within the ESA BIC program will be to define a space breadboard with our product. Our vision at Comper is to provide full circularity to the composites industry by allowing efficient repair and recycling. Such circular economy models have demonstrated the potential to save up to 50% of composite resources, which is totally in line with the UN SDGs. My name is Amael Koad, and this development directly follows my PhD thesis. Together with the incredible Comper team, we are the perfect combination to succeed and make a large impact with this technology on the market. Thank you.